Welcome everyone to this episode of Manufacturing Talk Radio. I'm Tim Grady. I'm here with Lew, who's the founder of Manufacturing Talk Radio. He's also the president of All Metals and Forge Group, a company that makes open die forgings and seamless rolled rings on very large hammers. And we are going to be talking with Bill Waldorf, who is the principal and senior structural engineer at Larson and Darby in lovely Rockford, Illinois. I just drove through Rockford on Sunday. Bill, thanks for joining us on Manufacturing Talk Radio.
You're welcome.
So let's talk about foundation, being the foundation of everything that goes into manufacturing. Love what you do. You can give us a couple of stories or horror stories, whatever you'd like.
Yeah. The design of these large machines, you need the manufacturer, when you buy one of these machines, is look at what the supplier, the machine tool supplier, asks for deflection requirements. That's how I got into this business. Company put in a foundation that didn't work, and they asked us, can you help us? At the time we were doing a building for Ingersoll Engineering, and so we looked at it, and I showed them the deflection problem with the foundation. These companies are looking for very minute deflections under moving load, measured in microns. And many of the companies load test the foundations when they're done to ensure the foundation's correct, so they can't blame the machine for non-tolerance. So it's critical that you start with somebody that understands what the machine supplier is asking for out of the foundation. And some of these foundations become 20 foot into the ground, depending on the size of them. So it's critical about this deflection criteria.
Bill, what happens over time? Now, All Metals and Forge is a manufacturer of open die forgings. They use 50-ton forged hammers. That shakes the ground a little bit. What happens over time with a machine like that, a big CNC milling machine with vibration and compression, soil compression or compaction?
We try to isolate our machines, so if there's a stamping press across the aisle, which happens a lot of times, we line it with essentially styrofoam to dampen it. Again, if you have a machine with 2,000-3,000 yards of concrete, it absorbs a lot of energy. But we're very conscious of that. And do we have to actually build an air gap or understand what it's setting on? Usually the mass of the concrete takes care of that for the milling machines. But I have seen where when they're milling apart a stamping process or a railroad, you'll see waves in the final milling, and that drives the manufacturing people crazy. So it's one of the first questions I ask is railroads, stamping presses, high forklift traffic. You need to look at that and ask those questions, and then how to isolate that foundation.
So for our audience, if they were to go and buy a piece of manufacturing equipment, they're not just buying a piece of equipment. They have to buy a foundation to hold their equipment firm, steady, no vibration, and so on, because everything is in millimeters and microns and so on. So when they go to buy a piece of equipment, it's not just $100,000 or $200,000 piece of equipment. They're also talking about a foundation. Now, do most manufacturers of equipment that sell to our audience, are they cognizant of the fact that, or is a manufacturer cognizant of the fact that they've got to be concerned about the foundation?
Hopefully the machine tool supplier is talking to them and trying to lead them down the correct path, that you may have $1 million foundation under your machine.
Wow.
And some of these big gantry style machines I've seen are $1.5 million. So the machine tool supplier needs to talk with his customer on what's required and make sure he understands the deflection tolerances he's looking for, how it's going to affect his factory when he digs this hole. In an existing factory, this is a challenge. I mean, we're talking, again, holes 20-foot deep sometimes, 100-foot long, 50-foot wide. That moving the dirt out of the factory is a big issue. Getting the concrete in is a big issue.
Oh my gosh, I didn't realize. When you said 20-foot deep, I thought, oh yeah, okay, I'm looking at something 6 inches in diameter, but 100 feet long and 50-foot wide, so almost a football field.
Yeah. Can I share a photo?
Sure.
Sure, do
Love
that.
to see anything like that. Now, what's this a photo of, Bill?
This is a photo of a large gantry machine for Komatsu up in Milwaukee. This is the first level pour.
Wow.
That's some of the holes we see.
It's a lot of concrete.
Again, this gantry moving back and forth is 500 and some thousand pounds, and the manufacturer was looking for 6 microns of deflection, 6 microns per meter deflection as that gantry rolls back and forth.
Now, when you say 6 microns per meter of deflection, define deflection for our listeners.
Okay. Anytime you put a load on a piece of material, it deflects. So as the gantry moves back and forth, this long bed of concrete gets a belly to it as the gantry rolls back and forth. And if you put a yardstick and pressed on it, or really, since this is continuous support, if you put your hand on your mattress, you see an indent. That's the deflection we're talking about.
Wow.
And the slope of that deflection, again, is measured in microns, which is a thousandth of a millimeter.
Wow. That's very tight tolerance. Bill, if you're allowing that kind of deflection in the concrete's laying on Mother Earth, do you do a lot of soil testing to see what kind of soil you're pouring on?
Yes, you need to understand. Up here, this photo you're looking at, and I can end that here, stop share. The photo, that plant is near Lake Michigan. The soil was bad. We had to put 60-foot deep piles to support it so it wouldn't sink into the ground. The piles are there to keep it from sinking. They do add some resistance to the spring value, but you need to understand how soft the soil is. It's, again, go back to the mattress reference. You can buy a firm mattress or a soft mattress. You sink more into the hole, which means it's got to be deeper to hit the tolerances. So yes, we need to understand the soil. A soft, sandy, springy soil causes your foundation to be deeper. A good rock soil will save you money.
Yeah.
But even rock moves, unless you're on a pure sheet of granite. The layers of rock around here with seams in them and stuff. When you're looking at these in small tolerances, even rock has deflection. So yes.
That particular photo that you showed us, how long does the concrete take to dry, harden, or whatever the terminology is?
Probably 60 to 90 days until it quits shrinking to the point where they can set the machine. I've learned the amount of concrete I can pour, anything over 2,000 yards, you begin to worry about heat. So I try to do my foundations in levels with a break at the neutral axis for bending. I can put enough vertical rebar to lock the two pieces together. But we see when the machine supplier goes to set his beds that if he does it before 60 days, he'll still see a small amount of movement. And what he aligns one day may be out of alignment the next week. So, yeah. It's probably still hot 6 months into it, but it's pretty well quit moving.
And what causes the heat? I'm thinking concrete. For the concrete, the water eventually evaporates or drains out of it. What creates the heat, Bill? Weight?
The heat of hydration. The chemical reaction of mixing the cement and water is a chemical reaction. Very critical in foundations is we use as least amount of water as possible in the mixes I recommend to keep all those factors down. I mean, what causes concrete to crack is shrinks, and we're designing this as a monolithic piece of concrete. Lots of rebar, very little water.
Wow. Incredible stuff. Now, you mentioned pre-show, we were just chatting with you, and you said talking in microns, if you put a piece of paper under a yardstick, you're out of
tolerance. That's the slope they're looking at. Under a load that is measured in hundreds of tons.
Oof. That's incredible stuff. So I'm sure in your industry, and you don't have to name names, but you can certainly tell stories, there's been a horror story or two.
Yeah, I'm working on one right now where they put the machine up, the machine supplier came, put his machine together, went to do the alignment test, and it didn't work. They got my name. I unrolled the drawings and said, yep, you're right, it won't work. It was so thin, it was just obvious.
Oh my God.
And right now they're digging a hole next to this machine and rebuilding another foundation. That is painful.
Yes.
Not even to mention expensive.
Yeah, you don't want to go to your boss and tell him that.
Yeah, right.
But for the most part, the machine suppliers tend to ask to see the drawings of the foundations ahead of time and say, are you sure? Do you think that's enough concrete? Does your engineer understand what we're asking for? And sometimes I'll get a call and say, can you help me with the depth? Sometimes they go back and look and try to understand. It's sad when you have an engineer go, I don't even understand what a micron is. And it's critical because I said a lot of them, they load test their foundation so they know if it works or it doesn't.
Can you see, Bill, with some of these installations as a 500-ton crane moves down that pathway, the concrete actually slope a little? Is it visibly observable?
Not visibly observable. We make sure that crane columns are separate from the foundation. The other example is these foundations are like a big ship on the sea. The top stays not level, but straight. So if it rocks under moving load or due to the soil tipping, the mass of the concrete, the block of the concrete stays straight. It doesn't matter if one end goes down a millimeter, as long as when you stretch a string end to end, you're still within that tolerance. I hate to use the word level, but it's straight. These machines rock. It scares the owner when I say your foundation rocks, but it does. As you move from one end to the other, it tilts, but the surface is still level, and that's what they're looking for when they're machining. If you have a long part on the bed, if the gantry is at one end and it's deflected too much, you're milling different than when the gantry moves to the other end. So it's critical when these machines they're selling that they can mill into microns. The foundation has to give them the strength to do that.
Right. I know that Lew's company, All Metals and Forge Group, does large forgings, and they, mill those large forgings for finished parts. And some companies that you deal with also do the same thing. I never envisioned a CNC machine or a large milling machine working its way down, for instance, a big piece of heavy metal and a heavy crane to get this finished part produced that could be, I don't know, 50, 60, 70 feet long and hold a very tight tolerance. That's incredible, Bill.
That's what they're promising the client, and that's what they look at, the foundation engineer to deliver. If you're milling a nuclear reactor core for the Navy, those tolerances are very critical. And those are big, volumes of steel inside and out that they're milling.
Yeah, it's always hard to imagine that size of a part. I'm used to the nuts and bolts out in my garage or my tool bench. not the stuff you're working with or Lew's company makes.
Yeah, a lot of these factories, you're looking at 150-ton cranes. That's the parts they're moving. And they want to mill those to the same tolerance as your lawnmower engine block.
Wow.
Going back to the beginning of our conversation, you talked about soil and the different types of soil, hard, soft, rocks, granite, and so on. What goes into analyzing the soil to be able to determine what you have to do to design a platform in which to pour concrete and so on?
You need to find a very good geotechnical engineer that understands the spring values of soil. The local person who does footings for small buildings, they're hoping for a 1/4 inch deflection in their building, and they're happy. They say plus or minus half an inch. And I can recommend geotechnical firms that understand what this spring value of the soil is. It's not so much the strength of the soil, it's how springy it is. How much will it deflect under a given load? Not so much how it'll carry. Most architectural engineers, we're looking at if we have 3,000 PSF soil that'll hold up our building, we're happy. And if it moves a 1/4 inch, we're happy. I'm looking for something in very small numbers, and you got to get the right geotechnical engineer on board to look at that.
You're another 2-3 digits behind the decimal point.
Yes.
It's incredible. Well, Bill, I want you to share for our listeners and viewers how they can get a hold of you. How did they get a hold of Larson and Darby? Website address, etc.
It's larsondarby.com is our website. And they can go there and find my address and my name, and I can look at foundation and talk to foundations with them. I've done probably 350 of these foundations, around the world. So a pretty good understanding of what goes into it and the questions to ask. How do you fit it into your building? Is it going to affect your footings? How much shoring do you need? A lot of times we're lucky and we catch a new building, and we can tell them, okay, you're going to put in a 15-foot foundation. You got to put your building footings down at that same depth, and you can eliminate shoring. That's the ideal situation. If you're in an existing factory, you need to understand what you're doing.
Bill, when you're talking, particularly an existing factory that may have been built 25 years ago, it's got a concrete floor you're going to cut through that didn't originally take that kind of load. How do you figure out what's beneath it? You know, how much soil is there? How much bedrock might you run into?
The geotechnical engineers will come core a hole through the slab and do a boring inside the factory. Or if we're lucky, we can find the original borings for when the factory was built and look at the soil. As I talked about the springiness in the soil, that factors in, but it's not a huge factor. From very poor soil to rock, it may be a couple feet in the depth of the foundation, but usually it's somewhere in between. It's more the load the client wants to set on his machine and the tolerances that have been, you know, asked for from the manufacturer of the machine.
And if you're at 50 feet wide, 100 feet long, you're running into situations where, well, that half down there is on bedrock and this half down here is on sand.
That would be a real problem because you'd have to get the rock out. You can't have it hanging up on one side. You know, we'd go to extreme care, and that's why I always go and look at the site before they pour concrete, that this foundation is free to rock, and it's not hanging up on the forms, it's not hanging up on a footing. It's got to rock like a boat in the sea, because if one end hangs up, it'll kink instead of a nice natural curve.
So from the time that you take on a contract to the time that you're pouring concrete, and I know there's a lot of variables that go into that, but what's the time frame from contract to pouring, typically?
Usually I tell my clients I want 8 weeks to draw the drawings and do the engineering. And then a couple weeks to bid it, 3 or 4 weeks to bid it. And, you know, in 3 months, they can be digging a hole. But my engineering time's gotten a lot better in the last 35 years. I used to be real nervous when I did this and spend a lot of time engineering, but experience helps.
Yeah,
but these are complicated, as they try to tell the client. And the contractor, this is more like building a swatch than a building footing. Again, let me click on a photo here. As you look at this photo, you see all the anchor bolt cans, the slots, the changes in elevation. And as Lew's probably aware, machine tool people deal in very small dimensions, not like somebody building a footing. You can, you know, where a quarter, half inch in a building's no big deal. They're looking at all those holes you see in this photo, a quarter inch plus or minus. And all the pits and the trenches need to be perfectly in place for the equipment to drop in. These are complicated pieces of concrete.
Yes, clearly they are. It's an amazing piece of work.
Yeah, and again, you look at the size of this, and that foundation is probably another 12 feet underneath where those men are standing.
And Bill, to give our audience an idea of what that means, 12 feet, how expensive is concrete?
I figure, and I have to look at my prices because everything has gone kind of haywire in the last year.
Yeah.
But typically on a big foundation, it's around $1,000 a yard. If when I'm done with my design, I add up all the concrete and multiply by 1,000, that's a good figure to use, depending on the site. We did one in the San Francisco area where the foundation costs more than the machine.
Oh, Jesus.
but it was in a horrible environmental area. The soil was bad. They were in groundwater that was bad. They were in the San Francisco area where everything is expensive. So that foundation actually cost more than the machine did.
Bill, you must, if you're in the San Francisco area or California, you must be concerned about more than a little soil give with Mother Nature and earthquakes.
The good thing about these foundations, it's a mass of concrete. It moves with the earthquake. The foundation isn't going to come apart. The machine on top of it may come apart, but that's somebody else's concern. But these are just big blocks of concrete and they shake with the earth.
Wow.
But the case on that machine, because of the environment, because of the water, we actually pulled the machine out of the ground 5 feet. So, the workers don't like that because they have to walk up and work on platforms, but it saved 5 or 6 feet of excavation in very expensive soil to, dispose of, because it was contaminated soil. They did not want to get into the water table because the water was going to come out in 55-gallon barrels and be disposed of. So, you need to look at things. Ask your client, can I raise the machine? This will save you money. The people working on the machine don't like it because they'd like to walk right onto the milling table, but instead of walking up and working off a ramp. But if it can save the owner several $100,000, they can probably afford the machine and the foundation.
Bill, if you could raise the machine, or can you raise a machine 12 feet so you can access it from the second floor?
That would be a perfect scenario. That you could build without digging. You pour the concrete above ground. Haven't seen that.
Let us know if you do, because we'd love to have you back if you run into some unusual situations and hear more about this.
We did a big job for Boeing in Portland, and they bought 8 machines, and they wanted to get a machine every 6 months, as quick as the manufacturer could supply them. When we did the geotechnical, we found boulders, 10-foot in diameter boulders. So we had to dig the entire hole for all 8 machines at once and build a basement for them. And then as we built the machines, we built the machine off the basement slab, moved the forms over, but then all the trench work that you typically see around these machines, all the hydrostatic pits, all went down in that nice basement. Just a beautiful installation. It was just the machine and a flat slab. Down below the floor was a very complex basement with all the wiring, all the hydrostatics, all the pumps, and the machine just sat up there by itself and looked very nice. But there again, looking ahead, what's going to happen if we would have had to stop and get an 8-foot boulder out of a factory? That would have become an issue.
Yeah, right.
So it's trying to understand what the client needs, what his long-term goals are. I'll see if I can recommend that to work off the second story and save digging that hole.
Yeah, that's right. Well, the Larson and Darby group clearly knows what they're doing. Bill, we appreciate you joining us and chatting a bit about what goes into putting a heavy machine into a manufacturing environment. Few people understand manufacturing to that degree and what it takes to put a plant in action. Thanks for being with us.
Okay. Yes. It's an exciting thing. To see these machines go in and work properly in the end, I'm always excited.
Oh, clearly, particularly the ones you're putting in, big gantries and the like. That's incredible work, Bill. Congratulations.
Thank
Bill,
you.
thanks, sir. Thanks for joining us today.
Okay. Have a good day.
You as
Thank
well.
you. And while you're out there surfing the web looking for LarsonDarby.com, check us out at JacketMediaCo.com, where you can find this episode of Manufacturing Talk Radio and all the podcasts we've produced over the last 9 years. Is it approaching 10 years, Lou? Is that where we're
November
headed?
13th, 2013.
Yeah, we're headed there. So everyone, again, thanks for joining us on Manufacturing Talk Radio.
Bye all.